Today we're going to learn about linear regression. So in linear regression, which is probably the simplest type of regression, we're trying to predict a number from data that follows a linear pattern. So for example here, let's imagine that we have data about the hours spent studying for an exam in a class and the corresponding score in the class. So if we're trying to build a regression model here, we might try to build a machine learning regression model that's trying to predict the exam score, and as input to the model, we only provide the hours spent studying. So if we're lucky, we might get data that looks like this, that follows a clear linear pattern. So the process of machine learning in this case, and in particular of regression, is to learn a line that best fits the data. So like this. And in particular, we're learning the y equals mx plus b. We're learning the m and the b. The y is the variable we're trying to predict, and the x is the input data. So we call m the slope and b the intercept. We call those the model parameters. The machine learning model is learning the values of m and b that fit the data x comma y. And we'll talk in a future video about how those patterns are learned. But if we already have a line that has been learned, so the m and b's have been learned, then we could easily make predictions using algebra 1. That is, we get a value for x, the hours spent studying. We go up to the corresponding point on the line y, and we make the prediction based on the line. So given an x value with the line, we can find the corresponding y value on the line, and that's how we make predictions. So the main challenge of machine learning is to learn this line that's going to best fit the data. And that process is called stochastic gradient descent. We will talk about that in a future video in this series, so stay tuned for that.